Today we're going to use Trig to do some problem solving. So in Google Classroom you can find this worksheet, and you can either print it and put your notes on the worksheet, or you can write your notes in your notebook. So number one, we have a guy wire is attached to the top of a 75-meter tower and meets the ground at a 65-degree angle. How long is the wire? So we can use a right triangle to solve this problem. We have the vertical is our 75-meter tower, and it meets the ground, the wire meets the ground at a 65-degree angle. So the wire is attached to the top of this tower, and where it meets the ground down here creates this angle of 65 degrees. We're looking for the length of the wire. So I'm going to call that length x. So now we need to decide which of the three trig ratios to use. So we're calling SOHCAHTOA to help us to determine that. Looking at the given information, our acute angle is 65 degrees. The tower, the length of the tower, is opposite that acute angle. So I'm going to just label that as opposite leg. And we're looking for the length of the wire, which is the hypotenuse of this right triangle. So opposite and hypotenuse, we're going to be using sine. So writing our equation, the sine of 65 degrees equals opposite over hypotenuse, that's 75 over x. So when we solve this, we can start by taking the sine of 65 degrees. You can either use your table or you can use your calculator, and rounded to the nearest 10,000th would be 0.9063. Now we want to solve for x, but x is in the denominator here, so we need to remove it from the denominator. 75 divided by x. To undo that, we can multiply both sides by x, canceling it out of the denominator there, and multiply the left side by x. So now 0.9063 times x equals 75, and we can finish up by dividing both sides by 0.9063. And we're just going to round our answer to the nearest whole number for these problems. So 75 divided by 0.9063 should come out to be 83, and we are working with meters in this problem, so that's 83 meters. All right, on to number two. When the sun's angle of elevation is 57 degrees, a building casts a shadow 21 meters long. How high is the building? So we're going to start again by labeling the different parts of the right triangle. The sun's angle of elevation is 57 degrees. You can see here where I have defined angle of elevation. So the angle of elevation is measured against this horizontal being the ground up to the sun. And we know that angle is 57 degrees. It casts a shadow, the building casts a shadow that's 21 meters long. The shadow is going to be measured along the ground. So the building is casting the shadow along the ground, and that's 21 meters. We're looking for the height of the building. That's the vertical here. And I'm going to label that x. So again, we're assuming this building is perpendicular to the ground, so we have a right triangle. So again, we need to decide which of our trig ratios we're going to use. So relative to our angle of elevation here, the 57 degrees, the building is opposite, and the shadow along the ground here is adjacent to that angle. So opposite and adjacent, we are going to be using tangent. So let's start by writing our equation. The tangent of 57 degrees equals opposite over adjacent, so x over 21. Again, using the table or your calculator, the tangent of 57 rounded to the nearest 10,000 is 1.5399. And this one's a little bit easier since x is not in the denominator. We can solve by just multiplying both sides by 21. So 21 times 1.5399 is going to give us, to the nearest whole number, 32. Again, we're measuring in meters, so 32 meters will be the height of the building. And now finishing up, one more problem, number 3. From the top of a lighthouse 20 meters high, a sailboat is sighted having an angle of depression of 4 degrees. How far from the lighthouse is the boat? So we have a picture here of the lighthouse being the vertical. At the top of the lighthouse is 20 meters high, so the lighthouse has a height of 20 meters. A sailboat is sighted having an angle of depression of 4 degrees. So an angle of depression is going to be measured from the top of this lighthouse against the horizontal. So we're going to have this imaginary horizontal line here. And the angle of depression is this angle. Notice it's outside the triangle. So this diagram is definitely not drawn to scale since this is only supposed to be 4 degrees, but for our purposes here, so we can see the angle a little bit better, we've drawn it like this. So now we need to remember one thing here. With our horizontals, we have parallel lines. So we have this imaginary horizontal. I'm going to draw a little arrow for parallel. It's going to be parallel to the ground. So we can use one of our parallel line properties, which says that alternate interior angles are congruent. So that would be these two here. The angle of depression is congruent to this angle here. So this angle inside the triangle is 4 degrees. We're looking to find how far the lighthouse is from the boat. That's going to be measured along the horizontal, along the ground. So from the base of the lighthouse to our boat here is the length we're looking for. So we're going to call that x. Now let's define the pieces we know. So opposite the 4 degrees is the lighthouse. So here's our opposite length. And adjacent to that is x. So we are going to use opposite and adjacent again. So we will have tangent of 4 degrees equals 20 over x. The tangent of 4 degrees is 0.0699. And again, we need to get x out of that denominator. So multiply both sides by x. 0.0699x equals 20. Finish up by dividing both sides by 0.0699. To the nearest whole number, that is going to be 286 meters. That's it.